Welcome to the deep dive. Today, we're tackling a topic that definitely makes most people shudder, probably even just hearing the name. We're talking about bed bugs. But our mission today isn't just the eek factor. We want to get past that visceral reaction and really dig into their hidden biology and, frankly, surprising history.
And you're right about that reaction. It's intense right now. These little guys have a huge hold on the global psyche. We've all seen the headlines recently, major outbreaks. Paris, hotels were closing for weeks.
Yeah, I saw that. And it's not just Paris, is it?
No, not at all. Toronto, New York, Chicago, they're all grappling with this. And what's really alarming, I think, is finding them on public transport.
Yeah.
That feels like a whole new level.
Absolutely. They're these incredibly stealthy, blood-feeding creatures, total experts at ruining your sleep, your peace of mind. So this deep dive, we're going to unpack how they evolved this very specialized parasitic life and why they're just so unbelievably successful at it, catching rides everywhere.
They really are the ultimate unwanted stowaway.
Yeah.
Perfectly adapted to us, to the human environment. They've been with us pretty much throughout human history, spreading to basically every city where people live.
Well,
Masters of hitchhiking on clothes, luggage, you name it.
let's get into that history because the timeline is
Yeah.
it's kind of staggering. Scientists, they used to have this simpler idea, right?
Uh-huh. The old theory was, they were sort of general bloodsuckers, became specialists relatively recently, and then boom, jumped to humans. Easy transition.
But that's not the story anymore, is it?
Not even close. That whole narrative just got blown up. The really amazing part is the discovery of a bed bug fossil. And get this,
Yeah.
it's 110 million years old.
Wow.
Yeah. That one just rewrites everything we thought we knew about their origins.
110 million years. Okay,
Yeah.
let's put that in perspective. Bats, which we know are common hosts for them today.
Right. Bats only showed up about 60 million years ago,
Yeah.
give or take.
So for at least 50 million years before bats were even around, bedbugs were already doing their thing, feeding on, well, we don't actually know what, do we?
Exactly. That's the huge evolutionary mystery. If they were around back then, when giant dinosaurs were roaming, were they bugging a T-Rex? Probably not. But
Yeah, maybe not quite. It makes for a fun image, though.
yeah.
What was the actual requirement? What did they need back then?
It seems they've always needed something very specific. Hosts, animals that return to the same stable spot every night. A nest, basically.
Okay, so big migrating dinosaurs are probably out.
Almost certainly. They likely went for smaller animals, things that nested consistently. They needed that reliability, that predictability.
So they didn't really evolve for us specifically, but when we came along, built houses, invented comfy beds, we accidentally created the perfect bedbug paradise.
That's pretty much it. We offered safety, warmth, a reliable meal ticket that comes back every night, and they absolutely took advantage.
Yeah.
The two main species we deal with now, the common bedbug and the tropical one, they are now experts on humans, adapted to our sleeping habits, our nice big rooms, safety from predators, hiding in, mattress seams.
Which really brings us to the core biological question, doesn't it? Why blood? Why evolve to drink blood? It seems like such a high-risk diet for a tiny insect.
It does seem risky, but hematophagy, blood feeding, it's actually surprisingly common in the animal kingdom.
Really? How common?
Well, estimates are around 15,000 different animal species drink blood, some exclusively, like bed bugs, others just, opportunistically when they can get it.
And it's an ancient strategy too, right? Didn't the first vampires, so to speak, show up ages ago?
Yeah, the earliest ones we know of were proto-mosquitoes. We're talking maybe 220 million years ago.
Wow.
And what's really fascinating is how often it's evolved independently. It's not like all bloodsuckers are related. Vampirism has popped up separately at least 6 times just in invertebrates. That tells you something.
That the reward must be pretty huge to make the risk worthwhile.
Exactly. And the reward is nutrition. Blood is just packed with energy.
It's super calorie rich, full of iron, salt, protein, fat. I always remember that comparison someone made.
Oh, the beer one.
Yeah, a pint of blood actually has more calories than a pint of beer. It's just this incredibly dense, ready-made food source.
It is. But there's a catch, biologically speaking. Blood is missing some crucial vitamins, B vitamins mainly, that insects need.
Ah, okay. So how do they solve that?
They have help, specialized bacteria living in their gut. These little guys act like tiny chemical factories. They take compounds in the blood and basically transform them into the essential nutrients the bedbug needs to absorb. A bit like how bacteria in a cow's gut help it digest grass.
Okay, gotcha. So they're ancient survivors. They found the perfect niche with humans, and they've got these internal helpers to process their weird diet. But still, feeding on a huge warm-blooded animal like us, that's inherently dangerous. We can just squash them or poison them.
Absolutely. Danger is constant, which means timing is everything. They can't afford to get caught.
So how does a tiny bug know when it's safe? When we're actually asleep and not just lying still watching Netflix?
They don't need to see the TV. They have this really effective three-step sensory checklist.
Okay, what's step one?
First, identify heat. A warm-blooded animal nearby. That's target acquisition.
Makes sense. Step two?
Confirmation. They detect carbon dioxide. When you're lying there breathing out CO2, that's like a big flashing sign saying live body full of blood right here.
The dinner bell. Okay.
Okay.
And the final check.
No movement. Once they sense the heat, the CO2, and stillness, that's the green light.
And then they make their move, find some exposed skin, and what happens next?
They insert their proboscis, like a tiny needle, and inject their secret weapon. This incredibly complex saliva. We're talking about a cocktail of around 45 different proteins.
45 proteins. What do they all do?
It's amazing stuff. It's full of anticoagulants, so the blood keeps flowing smoothly, doesn't clot up in their little feeding tube. And crucially, it has numbing agents, anesthetics.
Yeah.
That's why you usually don't feel the bite while it's happening. They get their meal and sneak away before you even know they were there.
Which leads to maybe the most dangerous part of the whole process for the bedbug right after the meal. They drink a lot, don't they?
Oh yeah, they drink about 6 times their own body weight in blood.
6 times? What does that even look like?
The transformation is just incredible, almost instant. They balloon up, become completely round, engorged, really cumbersome and slow. Think about a tiny bug, maybe 5 millimeters long, suddenly 6 times heavier. It's one of the most dramatic temporary size increases in the whole animal kingdom.
Like little hulks, these tiny blood-filled water balloons. That must be when they're most vulnerable, right? If you twitch or roll over.
Exactly. Squish factor is highest right then. But here's the amazing part. Even in that bloated state, they're surprisingly fast relative to their size.
Really? How fast?
They can still manage about 0.07 kilometers per hour, which sounds slow to us, but for a bug that just got 6 times heavier, covering a few meters back to safety in just a couple of minutes, it's impressive.
Just enough time to waddle back to the crack in the wall or the mattress seam.
Precisely. Once they're back in the colony, hidden away, they're good for about a week before they need to feed again.
And while they're digesting, the colony is growing. Because the young ones need blood too, right? Before each molt.
Yes, exactly. Young bedbugs, the nymphs, they need a blood meal to fuel the growth spurt for each molt. And they go through 5 of those nymph stages before becoming adults.
That explains the rapid infestations. How fast can a colony grow?
Terrifyingly fast. Just a single pair, male and female, under the right conditions, can explode into a colony of maybe 35,000 individuals in only a couple of months.
35,000. Wow. And the adults are tough too. They can wait around.
Incredibly tough. Adults can survive for months, potentially even up to a year in cool conditions, without a single blood meal. That's why infestations can persist in empty apartments or old luggage stored away. They just wait.
Okay, so they survive, they grow fast, and then there's reproduction, which I gather is, no, not exactly romantic.
Romantic is definitely not the word. The term scientists use is traumatic insemination, and it's pretty much as brutal as it sounds.
Traumatic insemination. Okay, I'm almost afraid to ask. What happens?
Well, the female actually has a normal genital tract, for laying eggs, but the male, he completely ignores it. Instead, he uses the penis, which is sharp, hooked, almost like a needle, to literally stab the female, usually in the abdomen, sometimes the chest.
He stabs her. Seriously, where does the sperm go then?
So insects have an open circulatory system, right? Their blood, the hemolymph, just kind of sloshes around their body cavity. The sperm gets injected directly into that hemolymph. It mixes in, travels through her body, and eventually finds its way to her ovaries to fertilize the eggs.
That is horrific. And effective, I guess. How many eggs can she lay after all that?
Very effective, unfortunately, for us. A single female can lay up to 10 eggs a day. Over her lifetime, that could total around 500 eggs.
500 eggs from one female. While being repeatedly stabbed by potentially multiple males, it sounds like utter chaos.
It really is. The females are passive in this. They just get stabbed. The wounds can get infected. Multiple males might inseminate the same female. Sometimes males even mistakenly stab and inseminate other males. It's just, yeah, chaos.
Given how widespread they are, how much they bite us, there's one really important factor here that we should probably consider ourselves quite lucky about.
Ah, yes. the disease aspect,
Hmm.
or rather the lack of it,
Exactly. As far as all the research shows, unlike mosquitoes or fleas or ticks, bed bugs do not seem to transmit diseases to humans.
which is huge. Think about malaria, Zika, Lyme disease,
Yeah.
all spread by other blood feeders. Bed bugs bite us constantly, but they don't appear to pass on those kinds of dangerous pathogens. That's a major silver lining, biologically speaking.
It really is. But that doesn't mean the bites are harmless, right? The itching alone can be maddening.
Definitely not harmless. Your immune system is reacting to all those proteins, those 25 proteins in their saliva we talked about. That's what causes the itchy bumps, the hives, the rashes for most people.
Though not everyone reacts, apparently.
That's right. Estimates vary, but maybe around 20% of people, 1 in 5, have basically no reaction at all. They get bitten, but don't get the itchy bumps. Lucky them.
For the rest of us, though, the problems can go beyond just itching.
Oh, for sure. Scratching constantly can break the skin, leading to secondary bacterial infections. That's a real risk. And then there's the psychological toll. Just knowing you have these things crawling on you at night, feeding on you, it causes significant anxiety, major insomnia.
Yeah, I can imagine. And in really bad cases.
In severe, prolonged infestations, people can develop delusional parasitosis. That's a condition where you feel like you're infested with parasites even after the bugs are actually gone. It's incredibly distressing.
So battling them is clearly crucial for health and sanity. But it's not easy, is it?
Not easy and not cheap. They're incredibly good at hiding tiny cracks behind baseboards, inside electronics sometimes. Effective treatment usually needs professionals. We're talking chemical fumigation, sometimes thermal treatments where they heat the whole place up to kill them, plus washing and drying everything on high heat. It's a massive undertaking.
Is research offering any new hope?
There's ongoing work. Groups like the Bedbug Foundation are looking into better detection methods, maybe using their own biology against them, like their attraction to CO2 or heat. But right now, if you suspect you have them, the absolute best advice is call an exterminator immediately. Don't wait.
Okay, so let's recap this deep dive. We've got these incredibly ancient creatures, 110 million years old. They figured out how to live on blood, which is surprisingly calorie dense. They do this crazy Hulk transformation after feeding, and their reproduction is, well, traumatic is the word.
Yeah, and understanding all the biology, how they sense us with CO2 and heat, how dramatically they change size, their sheer reproductive speed, it all explains why they're so incredibly persistent and successful today. They're not just dumb pests. They are genuine evolutionary marvels, perfectly optimized for surviving in the dark right alongside us.
And maybe that leaves us with a final thought, something for you, our listener, to mull over. Given that bed bugs evolved long before humans, and they needed hosts that reliably returned to a stable nest every single night, what other ancient creatures, 100 million years ago, had those kinds of nesting habits?
Right. What was the dinosaur equivalent of hiding in a mattress seam? Something to ponder.
Mm,
Maybe don't ponder it too much right before bed, though. Sleep
That's
tight.